All right, and we're back to it. All right, hope you guys have had a good couple of days, and we're going to jump right back into some more solving today. We're going to continue with our conversation about solving quadratics, and we're going to learn another tool today called the quadratic formula. All right, but before we get to that, as you can see, we have four warm-up problems here that's going to review basically what we've done the last lesson, which is solving by factoring. All right, so what I'd like you to do is give those four problems a shot. You can pause the video, you can take out the fully worked notes to check it, but give those four problems a shot, and check your work either by checking it with me on the video or with the full notes. So good luck. All right. So, just to save a little bit of time, once again, I have these four problems worked. So I'm going to flip to the next slide here so we can see all those worked. Now, one of the most important things that we've talked about so far with solving is that before we do anything, we want that equation to be equal to zero. All right, so you can see in our first problem here that the first step that you have to do is subtract 5 from both sides. This now gets our equation equal to zero. Now, what we want to do is solve by factoring. All right, now we look for a GCF. There is not one in this case, so we can jump right into our area model here. So our A term is here, our C term is here. So A times C in this case is 12. We have to add to our B term here, and I can see the mistake I made. Maybe you guys caught it here, and I'll just adjust this as we go here. All right, I left my signs off when I did this problem. It's a negative 7x, so that should be a negative right there, which means I would want a negative 3 and a negative 4 and a negative 3 and a negative 4 here. All right, now what that means is that this would be a negative 3 and this would be a negative 4. All right, and then let me come back, and that's a really important thing because what that's going to do is change our signs on our factors here, which in turn we'll come over here and I'll erase those there because those are no longer going to be positives. If my eraser doesn't freak out on me here. All right. So let me just kind of take care of all that real quick. Sorry about that. Best laid plans and everything. All right. So now, all right, that makes a huge difference because now we talked about this that if these two terms are both negative, that means I need to factor out that negative here. So instead of getting x plus 3 like what I had written, you're going to get x minus 3. Instead of x plus 4, you're going to get x minus 4. All right, and so then when I come over here, that now means that our factor is x minus 3 and x minus 4. So that means now x minus 3 would be equal to 0 and x minus 4 would equal 0, which means that instead of getting negative 3 and negative 4, we're going to get positive 3 and positive 4. So you can see how important those signs are. All right, so attention to detail. Don't make the same mistakes I make. All right. Now, moving on to problem 2. Once again, we want this equal to 0. We have to add 3 to both sides. We have like terms here, so 17 plus 20, or excuse me, 17 plus 3 is 20. Now, once again, when we look at this equation, there is no greatest common factor, so we can jump right into our area model. So our A term is here, our C term is here. Now, notice this time when we do A times C, we get 40. Now, this time I did pay attention to sign, so our B term is a negative 13n. So my combination would be negative 8 times negative 5 is a positive 40, and negative 8m plus negative 5m is our negative 13m. So I'm going to drop those two guys in here. We look at our greatest common factor vertically here. That would be just m. Our greatest common factor in our second column would be negative 4. Once again, we have that these two terms are both negative, so we're going to have to factor those negatives out. Now, when we look at our first row, we can see that our GCF would be 2m. And when we look at our second row, once again, it was going to be that negative 5. All right, so now if I come back over here, here's our first factor, m minus 4. Here's our second factor, 2m minus 5. Now, m minus 4 is equal to 0, which implies that m has to be 4. 2m minus 5 equals to 0. So that implies that 2m has to equal to 5. I can divide both sides by 2, and I get to 2.5. Or if you want to leave it as a fraction, you can leave it as 5 halves. All right, moving on to number 3 in our warm-up here. Now, when we look at number 3, we get this equal to 0 by subtracting 191 from both sides. I have like terms, so I can combine that. Now, when I get to this line, 8n squared minus 200 is equal to 0, if you think back to our conversation in the last lesson, we said if we don't have a b term, if b is equal to 0, we can use our normal solving process. We don't have to factor. So, what minus 200 is 0? 200. So 8n squared has to be equal to 200. Divide by 8, n squared is equal to 25. And then remember, when you take the square root, you're going to get two answers. You're going to get the positive root, which is 5, and the negative root, which is also negative 5. All right, and then finally, number 4 here. So I need to get this equal to 0, so I'm going to add 25n to both sides. Now, notice, unlike our prior 3 problems, there are no like terms here, so I just have to bring each term down individually. So 5n squared comes down, the 25n would come down as a positive 25n, and that negative 70 would come down right here. Now, once we've done that, we do have a GCF here of 5. And notice factoring out that 5 is going to make this a little bit simpler for us when we get to our factoring. So you should get n squared plus 5n minus 14 is equal to 0. A term in the upper left, C term in the lower right. A times C is negative 14. And then we have to add to get that positive 5n. So the combination we'd want is 7 times negative 2 is negative 14. 7n plus negative 2n is a positive 5n. Drop those two guys in up here. Our GCF in our first column is just 1n. Our GCF in the second column is a positive 7. Moving to our first row, our GCF here is a positive n. And in our second row, once again, both things are negative, so I'm going to take the negative out, and then our GCF for 2 and 14 would be a positive 2. So once again, we're going to carry down that GCF of 5. Our first factor is n plus 7, and then n minus 2. Now, like we talked about before, 5 can never equal to 0, so we don't have to worry about that. So n plus 7 is equal to 0. That implies that n has to be negative 7. N minus 2 is equal to 0, and that implies that n is equal to 2. All right, so there's a very, very big review of a lot of the principles that we talked about in the last lesson. Now, once again, this is the third lesson in a row where we're solving, which means that the idea is the same. We're still looking for those solutions. We're still looking for those x-intercepts. Now, the issue with graphing when we solve is that the x-intercepts aren't always exact. All right, we don't always get 2 or 5. We get some really different kind of numbers, like the square root of 3 maybe, which is not an exact number. All right, the issue with solving when we factor is that factoring doesn't always work. We have solutions that aren't always integers, that aren't always rational, and therefore we need another tool to help us find all possible solutions. And that tool is what we're going to focus on today. And the name of that tool is the quadratic formula. And I know I've mentioned this in some of the prior lessons that we would eventually get here. Now, the quadratic formula is a very, very, very important thing. It works all the time to solve a quadratic equation. All right, so we can use this all the time. It's something that will be useful to you not just this year, but next year, and really any year that you're taking and completing a math class, you'll probably at some point in time use the quadratic formula. So, getting into that. All right, so like I say, getting into our quadratic formula. Now, once again, we want our quadratic to be in standard form. All right, we will want it to be equal to 0 because we're solving once again. And so here is the quadratic formula. All right, so it is negative b, all right, the opposite of b, plus or minus the square root of b squared minus 4ac all over 2a. Now, if you notice, here's this negative b over 2a. We've been using that to find the vertex. That's the center of our vertex. All right, and that means that the two intercepts or the two solutions are equal distance from that line. Now, I'm not much of a singer. I don't have much of a voice. I'm not, in fact, allowed to sing in public or dance or clap because of the embarrassment it brings to my family. But here is a tune to help you remember the quadratic formula.
X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a.
Feel it in your heart.
X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a.
All right, now I apologize because now you'll be singing that for the rest of the day, hopefully the rest of your lives. All right, so that is the quadratic formula. So when do we use the quadratic formula? All right, and that is the same situation we've been talking about. All right, so when we solve. All right, so we use this to solve, right? So let me see, my pen is really slow at the moment. So to solve, right? And we said that those keywords, right, are, right? So the x-intercepts, right? All right. When we see the word solutions. All right. All right. Roots. I think that's what we said, right? Yeah, roots. Almost looks like a pair of eyeglasses there. All right. So there you go. All right. And so what do those solutions represent? It represents those x-intercepts, right? So that's what we want, is those x values, right, in the x-intercepts. All right, so there you go. Now, these are kind of the steps here, and I'll go through an example or two with you in just a moment. And I kind of do the 3 and 4. I think I'm going to actually do in reverse here because I think it's a little bit easier since we're going to be using our calculator to split it apart, and then we can just use our calculator to take the square root, and you'll see what I mean by that in a second. But all right, so the first thing we want to do is identify A, B, and C, which we've been doing lately anyhow when we've been trying to find our vertex. And remember, A is always the coefficient of the x squared term, B is always the coefficient of the x term, and C is the coefficient of our singular term out here where x is not there, right? X to the power of 0. All right, so the best thing I think to do is to let's just jump into an example and go through this. The nice thing is it is very formulaic. All right, it is very direct, but you do have to know the formula. So that's really the big thing that you have to do is work to memorize this. So once again, just hit reverse, go back and listen to that song. I know, it'll put you to sleep. It's so relaxing and peaceful. Oh. All right, so notice we want to solve this equation right here. It's equal to 0. All right, so like I said, the first thing that we want to do is identify all of our values here. So if we look, A is 5. All right, that's a really funky 5. B is 10. And C is negative 17. All right, so here's what we want to do then, is that we want to take our A, B, and C value, we want to plug it into our quadratic, and then we'll start getting into the steps here. So I'm going to do that right here. So x equals, so now once again it's still the opposite of b, so since b is positive here, that's going to be a negative, and that's going to be plus or minus the square root of all of that, right? And then it's going to be b squared, so 10 squared minus 4, and then a, and then C. Extend that square root there. All right, and then that's all over. All right. Maybe my pen just does not want to stop writing. All of a sudden, it's just going to go wild here. I think it's just so excited about that quadratic song. Just does not know what to do here. So let's try that one more time and see if I can get us a fairly decent line here. So there we go. All right, and then that's over 2 times A. All right, so there you go. Now, so what we want to do now is once we've entered everything, so plug in the coefficient in the equation, that's what we've done. Now what we want to do is just kind of do a couple steps here individually. We want to simplify inside this radical first. So I'm going to just go ahead and write x equals. All right, so that negative 10 on the outside of the radical is not going to change. So we're going to have negative 10 plus or minus. All right. And then what we want to do now is do this. Now we want to come right over to our calculator and we're going to type it just like it looks. So, all right, so 10 and then squared minus, and make sure you hit the minus sign, not the negative sign, 4a, and then c. Now this is negative 17, so this is when we want to use that negative symbol. All right, and be sure to include your parentheses. That really helps with the calculator. And so we get the square root of 440. So square root, and stop writing. So once again, that pen having some issues all of a sudden. It's the middle of the day here as I record this, so I think the system is really bogging down here. All right, so let me try this again. All right, so square root of, and then 440, and that's over 10. 2 times 5 is 10. Now, here's where I'm going to flip these because we're using the calculator. So I'm not going to take the square root yet. I'm going to go ahead and split these into our two answers. So one of our answers will be x equals negative 10, and then plus that square root of 440 over 10. And then our second answer will be x equals, and it's going to look exactly the same, so negative 10, but now it's going to be minus, that's what that plus or minus is there for, the square root of 440 divided by 10. And this is why I said I wanted to split it up first, because now what we want to do is we can just put this into our calculator here. So I'm going to go over here, all right, and so I'm going to just do negative 10 plus, and remember the square root is this little blue guy right here, so second square root, 440. And what I'm going to do is now I want to hit enter, and then I want to divide by 10. Now this allows us to get a little bit more of an exact answer versus having to take the square root and then round to get our answer. So our first solution is x equals, and I'm going to go to two decimal places here, so I'm going to go to 1.09. So there's our first intercept, and you can see that that's not an exact answer, or excuse me, that's not an integer answer. It's not a rational answer. It's not like 2 or 3 or something like that. So this is why we need the quadratic formula. Now to get the next answer, I'm going to come back and I'm going to do the same thing, but just with subtracting that radical. So negative 10, or that root, minus second square root of 440. And I'm going to hit enter here, and then I'm going to divide by 10. All right. And now we can see that our second answer here, x equals negative 3.09. All right, and that's the quadratic formula. Let's do one more together here, and then I'll have you do a couple by yourself, all right, to practice a little bit. And like I said, it really is just a matter of memorizing the formula, all right, and then knowing which order to perform all of your work in as you go through the quadratic formula. All right, so let's do this. I'm going to switch to blue here. All right, so when I look at my equation here, once again, I always have to make sure that it's equal to 0, which it is. All right, and then now I can go through and identify my a value as 9. All right, my b value is positive 5, and my c value is negative 9. There we go. All right, so now I'm going to take those values and I'm going to plug them into our quadratic formula. So x equals the opposite of b, so now that's going to be a negative 5 plus or minus the square root of, that's a, b squared, so 5, I really apologize, this is really having a very hard time keeping up, minus 4 a c, no, it's really bad. Whew. And poof, magic. Oh, look at that. Oh, nice, right? I just magically made that appear. Math is magical. But sorry, I just thought it might be easier the way things were slowing down if I just pause the video and try to do this a little bit better. But so b squared minus 4ac all over 2 times a. So if you need to pause the video so you can catch up, go ahead. All right, and so then x equals, all right, we still have that negative 5 on the outside, right? And then plus or minus. And then we're going to go ahead and do this on our calculator over here. So I'm going to do parentheses 5 squared minus 4 times a times c, which is negative 9, and get that answer. So square root of 349. So square root of 349. All right, and then we have in the denominator there 2 times 9, which is 18. All right, and so now this is where we want to split it apart so we can get our two answers. So x equals, all right, negative 5, all right, plus square root 349 divided by 18, and x equals negative 5. Now this time we're going to subtract that square root of 349 over 18. All right, and so now this will give us our two answers here, and we'll go to our calculator to do that. And once again, you can use your phone, all right, whatever you have, you can download something, just really something that can allow you to just find those values as easily as possible here. Equals, and x equals. All right, so I'm going to come back over to my calculator here. So I'm going to do negative 5 plus that square root, so second square root, 349, hit enter, divide that by 18, all right, and we get 0.76 for our first answer there. And then I'm going to come back and do negative 5 minus that square root of 349, hit enter, and divide by 18. All right, so negative 1.31. 0.31. All right, so now you've seen me do it a couple times, so here's what I would like you to do, is if you look, we have two more examples here, 3 and 4. Now, before you start, I do want to point out that this should be a positive 119 here in number 4. All right, so go ahead and correct that, make that a positive 119. And so what I'd like you to do now is on your own, do problems 3 and 4. And then you just need to check your work by either turning the video back on and seeing me go through these two problems, or using the fully completed note sheets that's posted on Schoology for you. So give it a go, and I'll check in with you in just a moment. All right, so once again, I have these problems worked out here. So let's take a look and see how you did. Now, once again, this is just kind of an observation thing. When we look at this, our A is 4. Notice we have no x terms. That means B is 0. All right, so if you do not see your x term, B is 0. We've talked about that a little bit before. Hopefully you're getting used to seeing that. And then C is negative 81. All right, so you can see how I filled everything into our quadratic formula. We still have this 0 sitting out here. All right, and so I have plus or minus the square root of 1296. I split those two up. I get 4.5, and I get negative 4.5. So, all right, so be ready to recognize when B is equal to 0. All right, now, so really, you're either going to have B equal to 0. It's possible you could have C is equal to 0 sometimes as well. You will always have an A value, because if you don't have an A value, then it would not be quadratic. It would be linear. All right, so if we scroll down to this one, all right, so A is 3, B is 4, C is that positive 119 that I had you correct there. Now notice what happens this time. We plug everything into our quadratic formula, and I get this negative number inside of the square root. Then when you go over to your calculator, all right, I'm not going to do the whole numerator. I'm just going to do what's inside of that. And it doesn't mean that you did something incorrect. It just means that we have a problem where, if I hit that, once again, no real answers. All right, that means that we don't have any x-intercepts. We don't have any solutions, and you are finished. All right, my friends, that wraps up our lesson on solving quadratics with the quadratic formula. Listen to that song as many times as you want. You can download it. You can play it on repeat, load it on your phone, make it your ringtone, whatever you must do so that you memorize the quadratic formula. All right, so once again, now it's your time to go practice a little bit, take a look at the homework. Let us know if you have questions. Email us, contact us, come hang out in the Google Hangout with us. We'd love to see your face, check in with you, see how you're doing. All right, in between now and then, take care of yourselves. We'll see you.